Hi everyone, it's Math with AUB. Today's frame is based upon the circle. Tiny formulas to be utilized in case of circle. The terms involved in the circle are what given by radius, a relation between radius and diameter, circumference, area of a circle, how to find area of the sector of a triangle, as well as the length of arc, any arc on the circle. Number one is Question number one. What is the circumference of a circle whose area is 100 pi? Area of circle is given to us. Area of circle is given to us 100 pi. We have to find the circumference while area of a circle is given. Area of a circle is 100 pi, 100 times pi. Area of a circle is given by pi times r square. Pi times r square is equal to 100 pi. Area of a circle is given by pi r square and area is itself given to us, that is 100 pi. Solve for r square is equal to 100 pi over pi, cancelled out. We have r square is equal to 100, taking square root, r square is equal to square root of 100. So square root of 100 is 10 because it is a perfect square quantity. It is a perfect square quantity. The radius is only variable for finding circumference and area. We have given area, now we are asked to find circumference. Circumference 2 pi r. 2 pi r, or some literature writes pi times c, pi times c. They are both equivalent. They are both equivalent. Why? Because diameter is equal to 2r. Value of diameter is equal to 2r. Instead of 2r, we can plug in d, or instead of d, we can write 2r. They are equivalent. They are equivalent. Value of radius is 10, 2 pi times 10. So circumference is equal to 20 pi. Circumference is equal to 20 pi. So right option in that case is 20 pi. 20 pi. Again, let's brief yourself. Area of a circle is given to us, that's 100 pi. Area of a circle is given to us 100 pi. Area of a circle is given by pi times r square. Pi times r square. Pi times r square. Solve for r. Shift pi here from multiplication to division. Pi cancel out, r square is 100. We are interested in r. To get rid of square root, taking square root both sides. R is equal to 10. This is formula for circumference 2 pi times r pi d. D is equal to 2r. D is equal to 2r. We are familiar. But r is equal to 10. T is equal to 20 pi. C is equal to 20 pi. That's the value of the circumference. Circumference. Next, what is the area of the circle? It is a converse type question. In that case, we have given area, there is also given area, and we are asked to find, in that case, we are asked to find area, circumference is given. While in the first one, we have given area, we are asked to find circumference. What is the area of the circle? Area of circle question mark. Area of a circle we have to find out. Okay. When circumference is given to us. Question number 2. Circumference is given to us, that's equal to pi. Circumference is equal to pi. We are familiar. Circumference is given by 2 pi times r is equal to pi. Circumference is pi, it is given to us. Circumference is pi, it is given to us. Formula for circumference is 2 pi r. Solve for r. We have pi over 2 pi. Pi over 2 pi. Cancelled out. R is equal to 1 upon 2. R is equal to 1 upon 2. We have radius. We can easily find the area of the circle. Area of circle is given by pi times r square. Pi times r square. Pi is the famous relation lambda, and r is equal to 1 over 2 square. Square of 1 is 1. Square of 4 is 2. R1 can write pi over 4 square units. Pi over 4 is square units. That's our area. In that case, we have given circumference, that's equal to pi. That's equal to pi. Circumference is given to us, it is equal to pi. We are familiar. Formula for finding circumference is 2 pi times r. Solve for r. Shift 2 pi here. Pi cancel 1 over 2. It is value of radius that we have just calculated. Area of circle we are asked to find. Area of circle is given by pi r square. Plug in the value of r, that is 1 upon 2, square of 1 is 1, square of 2 is 4. It is pi over 4 square units, that is area of the circle. Moving towards question number 3. Moving towards question number 3. That is, what is the area of the circle? Area of a circle we are interested to determine, while the given condition is what the area of a circle that is inscribed in a square. That is inscribed in a square. We have a circle, we have a square, and circle is inscribed in it. Inscribed means touching every side, touching every side. In that case, square is circumscribed while circle is inscribed. The figure that lies inside, we use the adjective inscribed for that. Inscribed circle, circumscribed square. Circumscribed square. Square is something bigger and circle is placed into it. That's the concept behind circumscribed and inscribed. The figure that has been inside touching every vertex is known as inscribed. Inscribed circle that has been inscribed in a square, that has been inscribed in a circle. What is the area of the circle? We are interested in the area of the circle. While area of a square is 2. Area of a square is 2. Square means all sides are equal. And formula for area of a square is given by area of a square is, in that case we have given area of a square is 2. That's 2. And area, formula for area of a square, length width both equal, x into x is equal to 2. 2 is given to us. X square is equal to x square is equal to okay, solve for x, taking the square root. X square is equal to root 2. So x is equal to under root. X is equal to under root. Now look at this. X is r under root 2 in that case. X is r under root 2 in that case. This complete is under root 2. Here it's under root 2. It is under root 2. Here it is under root 2. Under root 2. From this one can infer that it is x from square point of view and it is diameter from circle point of view. This every length is of under root 2, square root 2. That is square root 2 overall, or here that is also square root 2. If that is the case, it is known as line passes through the center, it is known as diameter. Known as diameter. Here our diameter is equal to the length of the square. Diameter is equal to the length of the square. Diameter is equal to the length of the square. Diameter is equal to the length of the square. Diameter is equal to the length of the square in that case. Length of the square. So x is equal to, or diameter is equal to, x is equal to d is equal to under root 2. We have diameter is equal to under root 2. We have diameter is equal to under root 2. If we have given r, we can easily find area of circle. If we halve the diameter, then we get the radius. If we halve the diameter, if we divide by 2 the diameter, we get radius. Under root 2 over 2. So we have r is equal to under root 2 over 2, under root 2 over 2, under root 2 over 2. And we are asked to find area of circle. Now area of circle is given by pi r square. I have pi is a constant, famous ratio number. Value of r is under root 2 over 2. Under root 2 over 2 square. I have pi. Square of under root 2 is only 2. Square of 2 is 4. Square of 2 is 4. Square of under root 2 is 2. Square and root cancel out. Square of 2 is 4. Applying table, I have area of a circle is equal to pi over 2. Area of a circle is pi over 2 in that case. Area of a circle is pi over 2 in that case. We have given and a circle that has been inscribed in a square. A circle that has been inscribed in a square, and we have given the area of the square is 2. Area of a square is 2. Area of a square is 2. We are familiar. All dimensions of a square are equal. X into x, length into width. X square is equal to. That is the formula for area of square. It is given to us 2. Solve for x. X is equal to under root. X is equal to. That is the side of the square. That is the side of the square. Just find the relation of this length of the side of a square to the circle. If we move this one, then it is going to be our diameter of the circle. Diameter of the circle. Diameter of the circle means side of a square, side of a square is equal to diameter of the circle. Is equal to diameter of the circle. We have side is equal to under root 2 is equal to diameter. If we halve the diameter, if we halve the diameter, if we halve the diameter, we are going to get radius. If we halve the diameter, then r is given by under root 2 over 2. In that case, diameter is equal to under root 2. That is r we have just utilized here to find area of a square. That is pi r square. That is pi r square. I hope that it's answer to your all queries. Moving one step further, question number 4. A square of area 2. A square of area 2 is inscribed in a circle. What is the area of the circle? Now, the things are going to be changed. Circle is going to be circumscribed. Square is coming inside. Square is coming inside. In that case, circle is inside. Circle is inside. Inscribed circle. Why? Square is a circumscribed square. Circumscribed square. Now we are going to change the situation in next question. Square is inscribed. Square is inscribed. Square is inscribed. Let's see and find out how. Let me erase this first. Question number 4 it is now. Question number 4 it is. I have, okay. A square of area 2, a square having area 2 is inscribed in a circle. We have a circle. In that we have to inscribe a square. Inscribe a square. All sides are equal. Figure is not drawn to scale, obviously. It is area of a square is, area of a square is 2. We are familiar. Length widths are equal. In that case, x square is equal to 2. So x is equal to under root. X is equal to under root. X is equal to same situation. Here, square is inscribed in a circle. Square is inscribed in a circle. In a circle. Now we have this is equal to under root 2. It's also under root 2. It's also under root 2. It's also under root 2. Now we have to generate here its relation to find radius or diameter. To find radius or diameter. Look at this. Look at this. It is going to be hypotenuse of the triangle. Hypotenuse of this right triangle. Hypotenuse of the right triangle are diagonal of the square. That is diagonal of the square. Hypotenuse or diagonal of the square. We are interested in that. Its hypotenuse according to this triangle. Its diagonal according to square. It is diameter according to circle. Its diameter according to circle. It is diameter according to circle. Just find this line. It is our diameter. Just find this diagonal. It's our diameter. Just find this diagonal. It is our diameter. Find this diagonal. It is our diameter. Then we are in a position to find radius and so on. Applying Pythagoras theorem. That's our base. That's our perpendicular. That's our hypotenuse. We have h square is equal to b square plus p square. B square plus p square. Hypotenuse, diagonal, diameter all are same. Let me write d for diameter. Base is under root 2 square. Perpendicular is also under root 2 square. So I have diameter square or diagonal square or hypotenuse square is equal to 2 plus 2. I have diameter square is equal to 4. So diameter is equal to 2. Diameter is equal to 2. We are asked to find the area of a circle, half it. If we half the diameter, diameter is 2, 2 over 2, it means radius is 1. Radius is 1. Radius is 1. Radius 1 means unit circle. Area of circle is given by pi r square. Now, pi r square. Pi, value of r is 1. That is only pi. That is only pi. Area of circle is only pi. Area of circle is only pi. Area of circle is only pi. That's our answer in that case. Any square having area pi, any circle having area pi, any circle having area pi is a unit circle, is a unit circle, is a unit circle, is a unit circle. Because here r is 1, r is 1, r is 1. If the area of the circle is pi, if the area of the circle is pi, then definitely it is a unit circle. Then definitely it is a unit circle. We have given a square that has been inscribed in a circle. Area of a square is 2. Area of a square is 2. Side into side, side square is equal to, side is equal to under root 2. Now this is under root 2, under root 2, under root 2, under root 2. We have discovered the relation. The diagonal, the hypotenuse is also the diameter of the circle, is also the diameter of the circle, is also the diameter of the circle. From right angle triangle point of view, it is our hypotenuse. From square point of view, it is a diagonal. From circle point of view, it is a diameter. It is a diameter. Solve for this applying Pythagoras theorem. Hypotenuse, diagonal, diameter, all are same. Let me write here diameter h square b square plus p square. Base is under root 2. Perpendicular is under root 2. Under root 2 square, under root 2 square. Diagonal, hypotenuse, diameter, there it is equal to. Diameter square is equal to 4. Diameter is equal to 2. If diameter is equal to 2, then we half it. Halve it. Halve it by dividing 2. R is given by d over 2. D over 2. Half the diameter to get radius. It is our radius. Area of circle is given by pi r square. Pi times 1 square means pi. That's area that I have just marked as well. Now next, the two questions based on arc length and area of the sector. Arc length and area of the sector. Arc length and area of the sector. Prior to this, let me give you idea. 2 pi radian means a complete round is equal to 360 degree. 360 degree. You should have fair idea how to convert degrees to radian. How to convert degrees to radian. Degrees to radian. Degrees to radian. Because in case of arc length as well as area of sector, this shaded region is a sector. This shaded region is a sector. This shaded region is a this shaded region. This shaded region is a sector. Let me draw this properly. This shaded region is a sector. For sector, we need angle in radians. Angle in radians as well as, oh God, that's 72. Okay, let me fix that later. So that is the relation. 2 pi radian is equal to 360 degrees. 2 pi radian is equal to 360 degrees. If we convert from degrees to radian, if you want conversion from degree to radian, just multiply by pi over 180. Just multiply by pi over 180. Just multiply by pi over 180. Just multiply by pi over 180, because 1 degree is equal to pi over 180 radian. 1 degree is equal to pi over 180 radian. Let's see how. 2 pi is equal to 360. Or 1 degree, shift this thing there. 2 pi over 360 is equal to 1 degree. Applying table of 2, it will become 180. So pi over 180. Pi over 180. 1 degree is equal to pi over 180. 1 degree is equal to pi over 180. If we change the situation from degree to radian, degree to radian, just multiply by pi over 180. Pi over 180. Pi over 180. Okay. What is the length of the arc? What is the length of the arc of RS? Here, this figure is mentioned here. Let me draw this here. Circle we have. This is our angle is of 144. 144. This is R. We are asked to find the length of this arc. 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 Arc length is given by R times angle. R times the angle subtended at the center. R times the angle subtended at the center, but in radians. In radians. We have this thing in degrees. R is mentioned here. Value of R is 10. Here 10, it's also 10. I have written radius. Radius is given to us, that's 10. Plug in the values. 10 times 144. It is in degrees. It is in degrees. We have to convert in radians. Just multiply by pi over 180. Pi over 180. 0, 0 cancelled out. We have 144 pi. 144 pi over 18. Applying it, table of 2. 9 times. Here 72 times. 9 8 the 72. 8 pi. 8 pi is the arc length in this case. Arc length is 8 pi. Arc length is 8 times pi. Arc length is 8 times pi. Arc length is 8 times pi in that case. That's the formula for arc length. That's the formula for arc length. Don't forget, we need angle in radians. We need angle in radians. We need angle in radians. That the relation 360 degrees is equal to 2 pi radian. Conversion from degree to radian, just multiply by pi over 180. From degree to radian conversion, from degree to radian, if you want to convert degrees into radian, just multiply by pi over 180. You are going to get your angle subtended at the center in radians. Second, we are asked to find in the same question area of the sector. What is the area of the sector in that case? Area of sector. Let me rub this erase from the start. Let me give you idea of a sector. What do you mean by sector? Same circle here. Sorry, ugly circle I am drawing. Okay, it's 10, it's 144 given to me. Pardon me, figure is not drawn to scale. Now we are interested in its area of sector. This line is only arc. This portion of any portion of circumference is known as arc. Any part of circumference boundary is arc. Now we are interested in the area of this one, and angle is 144 degree. Area of sector is given by 1 upon 2 r square theta, 1 upon 2 r square theta, where theta is in radians, we have 1 over 2, radius is 10, square, angle is again 144. We have to convert degrees into radian. From degree to radian, just multiply by pi over 180. It is in degrees, multiply by pi over 180 in order to convert this one into radian. 10 square means 1 upon 2 into 100 times 144 times pi over 180. Calculation, a bit calculation cancelled out. Applying table of 2, 9 times here, 72 times. Applying table of 9, 8 9 the 72. And here 2 5 the 10. I have 5 into 8 into pi. 5 into 8 into pi. 40 pi square units. 40 pi square units. That is area of sector. To find area of sector of a circle or arc length, don't forget to convert degrees into radian. By multiplying pi over 180. For area of circle, if you want to put value of pi, arc length or area of a sector, the angle must be in radians. That's the standard. Angle must be taken in radians. Okay. Moving towards final question. That is the seventh, a heptagonal type preparation. Seventh question of this figure. We have given the figure. Let me reproduce it for you. This angle is given to us 72. It's x. We are asked to find x. It is acute angle. Let me draw more appropriate, as elegant as possible. Okay. It should be an acute angle, 72. Good. It's x. Now, here it's a triangle. Now we are asked to find value of x. Let me reproduce this. It is radius. According to circle point of view. Two sides are equal. According to triangle, two sides are equal. It is isosceles triangle. Means their base angles are also equal. This is x, this is also x. Why? By virtue of isosceles triangle, from circle point of view, it is radius from center to any Distance from center to any point on the circumference, its radius. It's also a distance from center to any point on the circle. Circumference is also radius. Here, from triangle point of view, two sides are equal. If two sides are equal, then two angles are equal. Two angles are equal. And we know that the sum of all interior three angles of our triangle is 180. Means we have x plus 72 degrees is equal to 180. We have utilized a tiny fact that sum of all three angles of a triangle is 180. X plus x 2x. Shift 72 over there. 180 minus 72. I have 2x is equal. Now it's 108. Dividing by 2, I have 108 divided by 2. So x is equal to 54 degrees. X is equal to 54 degrees. So this x is equal to 54. It's also 54. 54 plus 72. They amount to 180. They amount to 180. Single x is given to us. Utilizing the fact it is radius, it is also radius, it is radius, it is also radius. From triangle point of view, these are the two sides. If two sides are equal, then corresponding angles are equal. Two sides are equal, then their corresponding angles are equal. It is x, it is also x. We have utilized the fact that sum of all three angles of a triangle is 180. So x plus x plus x plus 72 is equal to 180. 2x, shift 72 over there, 180 minus 72, 108. Dividing by 2, solving for x, x is equal to 54 degrees. It's my tiny effort for you guys on frame number 8 of 23. 8 of 23. 8 of 23. It's my tiny effort to give you some light how to prepare for geometry, especially circuit. Let's solve by itself. Next.